This conference will now be recorded.
Okay. On any data science project is to understand the project management methodology. And the methodology that we are going to discuss is called as CRISP-DM. CRISP-DM stands for Cross-Industry Standard Process for Data Mining. Cross-Industry Standard Process for Data Mining. This is one of the extensively used project management methodologies and heavily preferred also because it has a very structured iterative approach. It has 6 stages. CRISP-DM in total has 6 stages. Stage 1 is understanding the business problem. Stage 2 is performing data collection. Then you proceed further with the third step, which is data cleansing or data preparation, exploratory data analysis, or feature engineering. These 3 steps put together should consume 60% to 80% of the total effort. $60 to $80% of the total effort should be spent on these first 3 steps. If you're spending less than this, that means you're not, focusing on these steps. That is all it means. And then once you're done with this, once you have the data in the format that you need, you proceed further with the next step, which is data mining or machine learning. Once you build your algorithm, and here is where you build your algorithm. Once you build your algorithms, you proceed further with model evaluation. And finally, you deploy the model in production. Finally, we deploy the model in production. So let me open AI Spry, which is your learning management system. And Jagadish, are you there? Let me check whether our friend is there or not. He's not there. That's okay. I'll try to finalize. Okay. Let me open one of the batches. Batch, maybe this one. 27th. All right. This first slide, this has only these 6 phases of CRISP-DM. All the 6 stages that we have. Nothing much in this. However, you'll have assignment pertaining to that. Okay, you'll have to submit the assignment. And then let me go to module 2, data types. Okay. If you have any doubts on any slide, you just need to click on have a doubt. The moment you click on have a doubt, it asks you on whether you have a doubt in the subject or on the assignment. Type in your question, the slide number, submit. One of us would get back to you. One of us in the sense we have a lot of junior trainers who support us, and they are going to get in touch with you and help you get
Hey,
clarity on that.
can you show how to get to this module thing again?
Which one? Have a
How to
doubt?
get to, no, how to get to this page where you have these assignments.
Okay. The moment you log into your page using your username and password on AI Spry, you would be able to see this kind of a page wherein the course would be assigned to you. I mean, whichever module, or I would say whichever batch you belong to, that would be assigned to you. When you click on that, we come here.
Nice. Okay, thanks.
Yep. You'll have all the modules, quizzes, assignments, and hands-on material. We are trying to add another section called interview questions. Those will be very interesting because we want our participants to be very clear with all the sets of questions, interview questions, which could be asked in the interviews, right? And then that's going to set the tone. Okay. All the data sets, the R code, Python code, everything would be available in this learning management system. It is a one-stop solution for you. So all the data types, anything that I speak about would be available here. Okay, fine. Now let us get into the elementary understanding of certain key statistical terms. And I also observe this, that the moment we speak about probability, majority of the people feel overwhelmed and switch off their brains. How many of you all fall into that category? I mean, there's nothing wrong in that. I used to fall into that category during my school days, etc. Wherein the moment someone says probability, I was like, oh my God, it is back again. How many of you all feel that?
Me here, Sangeeta here.
Yes, Sangeeta,
I
you
feel
feel that?
the
Okay. Yeah, anyone else who feels that?
Sometimes.
Yeah, sometimes. Yeah. None of you all, none of the other people feel that? Oh, wow, wonderful. That means you all will be able to grasp the concepts very well. Now they are answering. Yes. Okay. Poonam. Wonderful. So let me write that. Probability is equal to. We will ensure that probability now would be scared of us. We would not be scared. Okay. For people who have phobia of probability, like me, I usually used to have phobia with mathematical equations, but then unfortunately that became my profession now. But yeah, probability is written as number of interested events divided by total number of events. Number of interested events by total number of events. And here, a random variable describes the probabilities for an uncertain future numerical outcome of a random process. This is exactly how the definitions would appear in your statistical books. I don't know about you all, but when I read this for the first time, I was like completely lost. This random variable describes the probabilities of an uncertain future numerical outcome of a random process. Oh my God. So then we thought, okay, let us explain these concepts to our participants in the way that we all would like to be explained. And then we thought, okay, let's split this down then into two components. Random variable, we are going to split this into variable and random, two components. Let us understand the first component called as variable. Variable means output of any event. If it varies, it is called as variable. For example, say you're flipping a coin. Would I always get a head? No. You can also get a tail. So you can either get a head or a tail if you flip a coin. You either get a head or a tail. So the output of this event called flipping a coin varies. And if you roll a die, die is singular, dice is plural, and if you roll a die, you might get a 1, 2, 3, 4, 5, or 6. You would not always get a 1. You might get 2, you might get 3, you might get 4, you might get 5, or you might get 6. Right? You might not always get a 1. So the output varies. If the output can take one of several possible values, then it is called as variable. This is the first component of random variable. Now let us understand the random component of it. Random means if there is a chance associated with each of these values, it is called as random. So if I say, or if I ask you, and what is the chance that we would get a head? Chance or probability of getting a head is equal to number of interested events, right? We'll go with this formula, okay? Yeah, it's 1/2 or 0.5, but how did we get that? Number of interested events is a single event. You are interested in a single event called head. So 1 divided by. What are the total number of events that we have? 2. So it's 1/2. What is the probability of getting a tail? Tail, number of interested events, you are interested in tail, and tail is a single event divided by total number of events. The total number of events are 2. 1/2. When you look at 1, you say, hey, what is the probability of getting a 1? 1 is a single event divided by total number of events are 6. It's 1/6. Question to you all. What is the probability of getting a 2? Yep. Can you all answer?
Same.
1/6.
2/6.
1/6.
1/6.
Okay. So usually I hear 2 responses. Usually that's normal. 2/6 and 1/6, right? But let's understand that. Number of interested events. Are you interested in a single event called 2? Or do you have 2 events here? 2 means what is the probability of getting 2 and 3? 2 and 3 means you have 2 events. If you're speaking about a single event called 2, it's 1 event. So the number of interested events are 1 divided by the total number of events here are 6. Probability of getting a 6.
1.
6. Yeah, 6 is a single event, right? Number of interested events are 1 divided by total number of events, you have 6. Wonderful. So what is a random variable then? Any variable which can take one of several possible values, like head or a tail or roll of a die numbers, and if it has chance or probability associated, then it's called as random. If you have both these components, it is called as random variables, right? If you have both these components, it is called as random variables. Simple. Then let us look at these questions that we have. Suppose you roll a single die Of course, die is singular any which ways. What are the total possibilities? So total number of events would be 6. What would those 6 be? 1 or 2 or 3 or 4 or 5 or 6. Yep. This we know anyways now. And then if the question is, what is the probability that the outcome would be bigger than 3? So I'm saying, what is the probability that, oh, one more thing I forgot. Random variables are always represented using capital letter. It could be a capital A or capital B or capital C or capital X or capital Y, capital letters. And this roll of a die is called as a random variable, and it is represented using a capital letter. And this takes all these values. And each of these is represented using a small letter. Each of the values of a random variable are represented using a small letter. Any book that you pick up for statistics, any book that you want to read based on statistics. Yep. These are the notations that you should be aware of. Capital X is a random variable. Small x are the values which random variable takes. Now, what is the probability that when you roll a die, you get a number which is bigger than 3? How do you represent? What is the probability that this random variable is bigger than 3? That's how you write it. And then you have to look at, okay, how many numbers do I have? The same formula holds true. Probability is
3 by
number
6.
of interested events. Yes. By
3 by
total
6.
number of events. Yes. So greater than 3, you have 3, right? 4, 5, and 6. 3 numbers. So the number of interested events are 3 divided by total number of events are 6. Very simple, very straightforward. Yep. Now, let's go to this second one. If I roll a die once, I know that I can get one of these numbers. And what is the probability that the outcome would be? Probability that the outcome would be equal to or bigger than 3. Greater than or equal to 3.
4 by 6.
4 by 6.
4 by 6.
Absolutely. Absolutely. It could be 3, 4, 5, or 6. So you have 4. 4 are the interested events, numerator, and total number of events are 6. 4 by 6. Wonderful. And if I roll a die once, what is the probability that the outcome would be smaller than 4? Yep. Anyone?
3 by 6.
3 by 6.
3 by 6.
Okay. How many numbers do we have which are less than 4?
1, 2, 3.
1, 2, and 3. Absolutely. Those are 3 numbers. So the number of interested events are 3 divided by total number of events. Total number of events are 6. Then finally this. What is the probability that the outcome would be greater than 2
3 by
3
and
by 6.
less than 6? I can write this as probability of x, which is greater than 2. I mean, greater than 2 can also be written in this way. Doesn't matter. And less than 6. This is how you write it. Okay, that notation is important because you can actually split this into 2. What is the probability that your variable is greater than 2 and probability of your random variable, that's roll of a die, is less than 6? You can either solve this and this separately and then add them up, or that's left up to you. But then here, let's go by the layperson strategy. Between 2 and 6, right? Greater than 2 and less than 6, you have 3 numbers. greater than 2 and less than 6, 3 numbers. So it's once again 3, which is the numerator, number of interested events divided by total number of events, which is 6. Now I'm sure no one will say that I don't know probability. These are all a few things which we would have discussed as part of our school days. It's a recap. I've taken you guys back to your school days. All right. But now that we want some money, we have to, increase the complexity a bit. Not heavily, but a bit. Let me see.
Can I ask a quick question, Bernie?
Yeah, Shripad. Yeah, Shripad.
Sorry. First of all, sorry I joined late.
Yeah, no problem. Yeah.
So talking about the previous slide, you said that a probability greater than 2 and less than 6, right? So if it is, it should be the addition of both, or you are talking a very mutually exclusive event?
We'll get there. For now, I'm not bringing in any complexity into this. A joint probability, conditional probability.
Okay, because I saw that, and that's why.
Yeah, we'll get there. As of now, nothing.
Thanks.
Nothing. Yeah. As of now, there is nothing of that kind. Okay. All right. Now that we want to earn money, we will take a different route altogether and try to understand something called as probability distribution. What is probability distribution? Okay. Let's look at this table. Say you have the daily sales data for a month, for the 30 days, for all the days of a month. You have the sale of Apple iPad. Okay, you have the sale of Apple iPad. And then if you look at these numbers, you sold 1 iPad on day 1. On day 2, you sold 4. On 5th day, you have sold 1. On 3rd day, you have sold 2. 4th day, you have sold 3. And then 2nd day, you have sold 4. In this range, you could sell your Apple iPads. This is the data which say customer has provided to you. And the immediate question that I have is sale of Apple iPads random variable or not?
Yeah.
Yep.
It is.
It is, right? Because what are the features or qualities of random variable? Output varies. Yeah, it's not the same. Output is changing, so it is variable. And each number has a probability. There is certain probability that you would sell certain iPads. How do you get that? I'll let you know. So this is a random variable, number 1. So output is varying. So you at least agree with me that it is variable. And is it random? Is a question. Let's answer that. So let's take 0. If I want to understand on what is the probability that on any given day you would sell 0 Apple iPads, then the same formula, probability, number of interested events. Say you count the number of times 0 appears. It's appearing once, twice, thrice, 4 times, and then say it appeared here also. I mean 12th day, 14th day, so on and so forth. Say it appeared 12 days out of total number of events are 30. When you solve this, you get a number as 0.4. So there is a probability associated with a random variable being equal to 0. There's a chance associated, probability, so it's random variable. What is the probability of selling 0 television sets? It's 0.4. Probability of selling 1 television set is 0.25. Probability of selling 2 is 0.2. I mean, it's same thing again. So let me give again this. Probability of selling 2 television sets. You just count on number of times you see 2 television sets. 1 time, 2 times. And then it would appear probably 3 times here, 4 times in that way. Say you sold 2 Apple iPads on 6 days. Interested events, number of interested events is 6. Divided by total number of events, say we have 30 days data, so you have to divide it by 30, and then you get 0.2. That's what is listed down here. Probability of selling 3 Apple iPads is 0.05, and probability of selling 4, once again it's the same thing. If you want to calculate probability of selling 4, you just count number of times you have sold 4 television sets. Okay, maybe you sold it once, maybe you sold it twice somewhere, maybe 3 times. So then if you do 3 upon 30, you get 0.1. Because number of times you see 4 is 3, assume that it's 3, divided by 30 because that's the total number of days, and then you get 0.1. So probability of selling 4 Apple iPads is 0.4. The point which you need to remember is that whenever you're given such data, you can convert that to a distribution called as probability distribution table. Why? Very simple, friends. I'm just distributing the probabilities for each of the random variables. I'm distributing the probabilities. And one more thing, if I roll a die, I might get a head or I might get a tail. Probability of getting a head is 1 by 2, and probability of getting a tail is also 1 by 2, right? Now, what is the total probability of all the events occurring? What is the total probability?
1.
1. Always total probability of all the events occurring would be equivalent to 1. That's it. Now, if I add all these probabilities here, would that be 1? Should that be 1?
It should be 1.
It should be 1. Exactly. So if you add 0.4, 0.25, all of these, it should turn out to be 1. So what am I doing? I'm taking the probabilities and then I'm distributing it across these values, random variable values, and hence it is called as probability distribution. Either you represent probability distribution in the form of a table or you visualize it in a graphical format, doesn't matter, however you're comfortable with. If you want to represent in a graphical format, then yes, it's a simple bar chart wherein you have x-axis and you'll have y-axis. On x-axis, you'll have random variables. On x-axis, you'll have random variables, 0, 1, 2, 3, 4, or events of a random variable. On y-axis, you'll have probabilities. And probabilities range from 0 to 1, you know that. Probability of selling 0 iPads is 0.4. Probability of selling 1 is 0.25. So you draw a bar which reaches 0.25. Probability of selling 2 television sets is 0.2. Probability of selling 3 television sets is 0.05. Probability of selling 4 is 0.1. So on and so forth. All right, simple. Either you represent your probability distributions as a table or as a graphical representation, doesn't matter. Whatever you are comfortable with, you can do that. Very, very important. Very, very important. I mean, these are, you might feel that these are very trivial and mundane stuff that you're learning, but trust me, these are extremely imperative. We will then discuss about probability distributions, a lot of those. Then you should not sit back and think, hey, what does probability distribution actually means? You should be confident that, okay, I understand that, when you have data can be represented in a tabular format, and I can distribute the probabilities against each of the random variable values. That's called as probability distribution table. This table can also be represented as a bar chart, okay, which is called as probability distribution table. Very important, friends. I mean, you might feel that, hey, this is trivial, I understood everything, but then no, this is very important. When I say density plot, I will say on y-axis you need to have probabilities. Then you shouldn't be like, okay, when did we discuss that? We discussed. Okay, all right. Can you all please answer this question? What is the probability of a sale happening?
0.6.
Yes.
When do you say that you have sold something? When can you say that you sold something?
Anything that's not 0.
Yeah, when it is not 0. I mean, when you sell at least one, right? So you write this as probability of the random variable taking a value which is greater than 0. It should be more than 0. It should be 1, 2, or 3, or 4 in this case. So you just write this as probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 and plus probability of x equal to 4. What is x equal to 1? Probability of that 0.25. What is the probability of x equal to 2? It's 0.2. Probability of x equal to 3 is 0.05 plus probability of x equal to 4 is 0.1. You all must be thinking, hey, why are you writing this? You could have counted. I could have counted, but we are getting used to small mathematical equations here. You all shouldn't be scared of math, right? So that's the reason why I'm using very trivial math. Okay, then that's right. You just take all these probabilities and add them up. Or if it's not 0, it's 1 minus.
One.
Yeah. Okay. What is the probability of selling at least 3 iPads? At least 3 iPads.
105.
Yes. How do you write it? I mean, you say, what is the probability that you sell at least 3? That means greater than or equal to 3. At least 3 means 3 or more than 3. So you write it as probability of x equal to 3 plus probability of random variable. I mean, you selling more than 3 iPads. Then probability of selling 3 is 0.05. I mean, you can write it here. For this, it's 0.05. Probability of x equal to 4 is 0.1. And then when you add these two, you get 0.15. Simple. That's probability distribution. Now, the question that I wish to ask you is for this data, is the probability distribution called as continuous probability distribution or discrete probability distribution? What is this called as? Yep. Let me see how many of y'all will get it right.
It is discrete probability distribution.
Mixed responses. Okay. Let me look at the chat window. A lot of y'all are mixed responses. A few of y'all are saying continuous. A few of y'all are saying discrete. Now here, continuous, discrete. Okay. Continuous data means that data which can take decimal values. So sale of Apple iPad. Can I sell 1.47 iPads? for the sale of Apple iPads, can I sell 1.47 iPads? Can I do that? Or
No, but but does it matter like 0.0 if do you have to actually put decimals when it comes to actual data?
Apple iPads, on day 1 you sold 0, on day 2 you have sold 4. Would you ever sell 3.75 iPads on a single day?
No, that's a straight no.
That's it.
But in a table, do you usually represent like 0.0, 4.0, 2.0, or it's nothing like that? That's not a thing.
Yeah, you shouldn't consider that. I mean, 3.0 is nothing but 3 only,
Okay.
right? So if you represent something in decimal format, and if it does not make sense, then it's discrete data. So continuous means decimals are accepted. Here, you cannot put 2.98 laptops in that way, right? So this is not continuous data. Continuous data means in decimal format. Otherwise, if you cannot represent something in decimal format and if it does not make sense, it's called as discrete data. And if your random variable is discrete, the underlying probability distribution would be discrete probability distribution. And instead of sale of Apple iPads, the count, if I were to give you the actual sales such as $270.15 in this way, if I give you the actual values or the sale values in dollars, then what would the underlying probability distribution be called as?
Continuous.
Continuous.
Simple. Absolutely. If instead of the count of Apple iPads sold, if I give you the amount spent or money collected or the revenue, then it would be represented in decimal format. And it makes sense. Here in this scenario, it makes sense. If it makes sense, the random variable would be called as continuous probability distribution. It's called as continuous probability distribution. Yep. Right. This is a continuous variable and the underlying probability distribution is continuous, right? This is how you figure out on whether your probability distribution is continuous or discrete. Are these concepts important for us? What kind of use cases? Simple probability. Yeah, what kind of use cases are getting resolved? Let me tell you that. A few mathematicians, in conjunction with physicians, they predicted that Angelina Jolie, she would have breast cancer. And because of that prediction, she has undergone double mastectomy. Mastectomy is removal of the organ. So both of her breasts she got removed surgically because people have predicted with certain probability. And her then husband Brad Pitt was, all he went all out in praising her, saying that she is a real hero. Based on probability values, people are taking decisions. That's a huge decision. And then there is an article on BBC News, which is Amanda Knox and Bad Math in quote. And then here in this, there is another write-up about a person called as Lucia Dieberg. She was a Dutch nurse, Holland, Netherlands, Dutch nurse. And then under her supervision, a few kids died. A few kids died under her supervision. And then judge has imprisoned her to life, sentenced her to life in prison. And then a mathematician came to her rescue 6 years down the lane. 6 years she spent in jail, and then a mathematician came to her rescue by bringing in all the probability aspects. And then he proved to the judge that, hey, the probability that she was involved in the murder of the kids is, 1 divided by, or it was 0.0000001%. It's absolutely 0%. then how could the judge sentence her to in prison for the rest of her life? And based on those probability values, she was acquitted. She was released after 6 years, however, that has happened. So very powerful. I mean, judges and in the judiciary, people make use of probabilities to a great extent, and not in all the cases, but in all the high profile cases, they make use of probabilities in a big way because they don't want to go wrong. They don't want to just back their decisions based on gut feel and the evidence is provided by the lawyers. That's how powerful probability applications are. We will discuss about another concept, and then we will take a quick break, and then we'll get back to this. Yep. So here there is something called as inferential statistics, and I'll explain this using COVID-19. I mean, how many COVID-19 cases do we have overall? Any guess on as of yesterday? How many across the globe? Let's see. It's 5.5 million approximately. Okay, 5.6 million people are tested positive on the planet for COVID-19. And then say Gilead is trying to come up with a vaccine or a drug, whatever suits well to counter COVID-19. And they're experimenting with something called as, did I spell it right? Yep. Not sure to what extent that is going to be effective. A lot of clinical trials going on. Anyways, so then if these people were to launch this drug or vaccine across the globe, then it has to undergo approval of US, because that's a US based firm, Food and Drug Administration. And this US Food and Drug Administration would ask them, and hey, did you do proper testing or not? Gilead has to prove that, yeah, I've done sufficient testing. And then it cleared all the stages or phases of clinical trials. Here, they obviously cannot go after the entire population. This is the population for us because we are speaking about all the COVID-19 positive cases. We cannot, or any company potentially cannot go after the entire population. That would be a Herculean task, but then, the COVID-19 might not even exist. Okay. Of course, you can speak saying that, hey, mutations are changing, so no matter what vaccine comes out, it would not be effective for the next mutation of COVID-19. All that is fine, but I'm just giving a generic view here. So COVID-19, 5.6 million people, that's the population. Gilead, for them to do clinical trials, they are first going to decide upon a sampling frame. They might say that, do you know what, USA and Brazil, probably I'll choose these two locations as my sampling frame. Or maybe I will choose the first or the top 5 countries with highest number of infections as a sampling frame. Why? Because they cannot go after the entire world population. You cannot effectively go after the entire world's population, right? And then what you do is, on this, you apply simple random sampling. You apply simple random sampling. Simple random sampling is a blindfolded technique. It is the gold standard. It is one of the best techniques when it comes to sampling, which is completely bias free. There's no bias. I mean, you're not doing strategic sampling here, saying that in US, let me go to each and every state and let me drill down to each and every, ethnicity, and then let me go to each and every gender, different age groups, and then let me pull that strategic, stratified sampling. We're not doing that. In statistics, majorly we rely on simple random sampling. It's the best technique, mind you, gold standard. You just close your eyes and pull randomly a few people, assuming that all these people are just juggled. You think about all the people who are infected with COVID-19, their names written on a piece of paper and put in a box, and then you juggle it completely. You mix, and then you randomly put your hand in and pull out a few names, and whoever name comes out, you go perform a clinical trial or test this drug on them. Okay, so you're applying a simple random sampling and you'll get a sample. Probably you'll take 10% of the COVID-19 cases of USA and Brazil, maybe, or 5% or 2, whatever be the count. But the point is you're trying to draw a sample from the population using simple random sampling. And say the clinical trials have shown positive results. The clinical trials have shown positive results, assume, on the sample. Then what do? You make statements about population. You'll say that clinical trials have shown positive results when we use remdesivir, and then that can be used for the entire populations, entire population. So in some sense, you're trying to draw inferences from the sample about population, and hence it is called as inferential statistics. Inferential statistics means you work on a sample, but you make statements about the entire population. Though you work on a sample, you make statements about the entire population. This is called as inferential statistics. And one more thing. If you say you got access to the complete population and you're working on the complete population, assume for now, you'll never do that. But say you're doing that. First thing is you will never get access to the population. Second, even if you get access to the population, you would not want to work on the complete data. You want to apply a sampling strategy and then work on a sample. However, you would be drawing inferences about the complete population. Now, when you calculate anything such as average, etc., what is the average age of all these 5.6 million people? So questions of that kind. When you calculate, those values are called as population parameters. Population parameters. When you work on a sample and calculate what is the average age of people who are infected with COVID-19 in this 10%, then the average is called a sample statistic or sample statistics, SSPP, population parameters sample statistics. Okay. What's the time? Yep, we will discuss this and then we will take a break. So whenever data is provided to you and when people ask you to perform analytics, okay, of course, as part of inferential statistics, you get the sample, and on that sample, you perform something called as descriptive statistics. Okay, you perform something called as descriptive statistics or descriptive analytics. And in this descriptive statistics or analytics, the first step is called as measures of central tendency, or this is also called as first moment business decision. This is also called as what? First moment business decision. Why is it called as first moment business decision? Okay, let me take an example of some retail store which is famous across. Let me say 7-Eleven. 7-Eleven is an American Japanese conglomerate which has retail stores across the world, not in India, but then in US, in Middle East, in ASEAN countries, ASEAN, right? ASEAN countries, and in a lot of places. Say you are CEO of 7-Eleven, a retail store, and say you have your, branches in Malaysia, Singapore, and say you have branches in Indonesia. 3 locations. What is the first question that you as a CEO should ask and would ask? The first question which a CEO would ask is, on an average, what are our sales? On an average, how many people do we employ? On an average, what are our profits? On an average, how many products did we sell? On an average, how many people visit our store? These are the first set of questions which any management person would ask and should ask. Hence, these measures are called as first moment business decisions or measures of central tendency. If you're not asking as a senior management person these questions, then yeah, it would be challenging. I mean, they would ask. They will have that maturity. They understand these things and they would ask. They go in a structured manner, right? Successful people go in a structured manner. Okay. So what are the 3 measures of central tendency? You have mean, median, and mode. Mean, median, and mode. So let's solve that. And you have population and sample, both of these. So let me open an Excel sheet here and try to help you all understand about mean, median, and mode. Okay. Say I take a small data set wherein I have 5 numbers. Okay. Now, if I say calculate the mean or average of this data set, what would that be? Yep. Can you all tell me what will be the mean or average of this data set?
It would be 3.
3. A lot of you all have started responding that it's 3. Okay. How do you calculate? It's pretty simple. You say summation of I equal to 1 until n xi divided by n. You might ask me this question, what is this capital Xi? I mean, is this a random variable? Yes, it's a random variable, right? And what is the notation you give to each of these values? You give a small notation, x1, x2, x3, x4, and x5. Right, that's the notation that you give. So If I substitute I equal to 1, it becomes x1 plus I equal to 2x2, then x3, then x4, then x5, divided by how many numbers do you have? 5 numbers. So you say 5, n equal to 5. Then just substitute x1 is 1, x2 is 2, x3, x4, and x5. You divide it by 5, and then you get 15 by 5. 15 by 5 is nothing but 3. So the mean or average happens to be 3. Very simple. Let me take another data set. I'm going to copy the same stuff here. I'll call this as dataset B, and I'm going to change this number from 5 to 700. I'm going to change only a single number from 5 to 700. Then if you calculate the mean of these numbers, what do you think will be the mean or average? It will be 142. Was I fast in calculating? Was I fast, friends? Yeah, I mean, a lot of people think that, yeah, I mean, he calculated it in a very fast manner. But the answer is, I've been training for the last 7 years, 8 years, right? The same example. So I kind of by hearted this number. Okay, not that I'm fast. All right. So it's 142. It's going to be 142. Why is it such a big number? Because of this 700, and this 700 is called as an outlier or extreme value. This 700 is an outlier or an extreme value because in comparison to the other numbers, this is an entirely different number. This is 3, this is 142. I mean, mean just because of one number, just because of a single number, your average changed drastically. It changed drastically, right? And so mean is something which gets influenced by outliers. And whenever you have outliers, mean is not a good measure. You shouldn't be using mean. A lot of people mislead you. How do they mislead you? Okay, let me erase this. Say there is a US, say there is INSEAD, which is a B school, #1 B school. And they might claim that people who get graduated through us on an average get $300,000 as a per annum salary. And then you might get carried away saying that, oh my God, it's a whooping 300,000 US dollars. So let me do my MBA here. But then you fail to understand that people graduating from INSEAD might also get 60,000 US dollars per annum. There might also be people who might get 80,000 US dollars per annum, right? And there might also be people who might get $1 million US dollars per annum. 1 or 2 people would get that. Then if you look at average, AVERAG, average of these numbers, let's 38. So let me put 80,000 here. Yep. Let me put 70,000. Let me put 60,000. Yep. So if you go by average or mean, the statements which this B school would do is, on an average, the students who get graduated through us make 300,000 US dollars. That's the average salary that they get. But you are missing out an important thing, that almost everyone will get salaries in the range of 60,000 to 80,000 US dollars. There will be 1 or 2 people who will make it really big in terms of $1 million US or so. And when the B school includes that also in their calculation, then you would be easily misled. So when you have such outliers in your data, you should not be using average. I mean, for that case, any good B school doesn't do that. I just gave an exaggerated example of INSEAD, but no, they don't do that. Financial Times top 100 B schools for that case, I have never seen them misuse, the data and then misrepresent that. They never do that. Anyway, so average is something, or mean is something that you should not use when you have outliers in your data. Then which measure should I use? You have to use something called as median. Median is the middle value of a data set. The middle value of a data set. What is the middle number of this data set? 3. Yes, that's the middle number. And what is the middle number of this data set? It's 3. Is this median getting influenced by this outlier? No. That's the beauty. But then a few of the other brilliant minds in the class might ask me that, hey, what if the data is like this? Now, what is the middle number of this data set, friends? Anyone?
700.
700.
Then my answer to you all is, you have to first sort it in a sequence
3.
and then
Yes.
choose the middle number. Okay? Because median should not by definition be influenced by your outliers, right? Median will not get influenced by the outliers. Okay, does not get influenced by outliers. Okay, if it should not get influenced by outliers, then the way you calculate that is you arrange the data and take the middle number. A few other brilliant folks in the class might ask, hey, that's fine, but what if you have even numbers? Here you have odd numbers, 5, then you pick the middle number, good. But what if I have odd numbers? What is the median going to be for this data set?
Average of 3 and 4.
Exactly. Since you do not have a single number, you take the 2 numbers and then take the average of that. Okay, you take the middle 2 numbers and take the average of that. That's going to be 3.5. Simple.
Hey, Brittany, one very simple question. What is the use? Like, can you give examples on like what scenarios is mean used in or median used for?
So if I give you a data set, any data set of, say, your organization sales, what is the first thing that you need to do? If I give you sales of your company for the last 10 years, what is the first thing that you need to do? What is the first moment business decision? What is the first thing that you need to do?
Check the
Calculate the
performance.
average. You check, no.
To check the average.
Yeah, exactly. Why? Because we are now data scientists, right? We need to analyze the data in a structured manner. You agree with that? Then what is a structured approach? First, you proceed with first moment business decision. The moment data is given, we don't jump into building prediction models. You don't analyze the way you want. You analyze it in a structured manner. When I say analyze in a structured manner, you have to go with first moment first. Then you proceed with second moment business decision. Then you proceed with third moment business decision. These are all the structured steps. And this is how you have to give your report to your management. Okay. And when you do this, you will say on an average. sales are so much. If your data has outliers, then what would you do? You go with median.
Got it. Thank you.
Yeah, making sense? So this is exactly how we need to solve. And these are called as descriptive analytics or descriptive statistics. After this, you go ahead with further analysis. But this is the first set which you need to do, and then you need to present a report to your management in Word document or PowerPoint presentation, however suits, whatever suits you. Yeah. All right. So when do you use mean? Yeah, when there are no outliers, but when you have outliers, you use median. Now I have another thing. After this, I promise that we will take a break. Understand it's quite some time now. So say I'll take a data set and say there is a psychology department which is trying to conduct a survey. On a jovial note again. Okay. Say they go to all the households, you know, of married couple, and then they ask husbands on, hey, are you happy about your married life? They'll say, I'm happy, because wife might be watching him. Another person, maybe his wife is not at home, so he'll say, I am unhappy. Another person, though his wife is not at home, he's so scared to say unhappy, so he'll say neutral, happy, so on and so forth. Say you have such data, some survey conducted, and then say you have such data. Here, what is a mean? Yep, what is a mean, friends?
We can't find out mean here.
Uh-huh.
So we have 3 happy, 1 unhappy, 1 neutral.
But
Neutral.
what is mean?
Should be
No,
happy.
you cannot calculate. Mean cannot be calculated when you have this data, and this kind of data is called as categorical data. Categories. Okay. Can you calculate median?
Nope.
No. Then how do I calculate? I mean, I cannot always expect numbers in my data, which my organization gives me for analysis. There might be categorical data also. Then you need to use mode. Mode is that value which repeats maximum times. The value which repeats maximum times is called as mode. And which one is getting repeated maximum times? Happy. So in short, this survey concludes that husbands are happy in general. On an average, in general, they're happy. That's the statement that you can make. If you have a single mode, it is called as unimodal. Okay, it's called as unimodal. And say another person also was surveyed, and that person told, hey, I'm unhappy. And say another person also says, I'm unhappy. Then what happens? What is the mode of this data set? Happy is getting repeated 3 times, and unhappy is also getting repeated 3 times. So you'll have happy as well as unhappy. So you'll have 2 modes. Bimodal. Bi means 2. Remember that. If you have greater than 2 modes, then it's called as multimodal. When do you use mean? When you have continuous data or when you have count data, and then basically when you have numbers, you use mean or median. But then if you have outliers, you prefer median. Simple. And when you have categorical data, you use mode. You can have a single mode or 2 modes, or you can have multiple modes. All right. So, yep, as I've told you, after this, we will take a break, and so will we. And then we will come back and then take this discussion further. Let us take a quick 10 minutes break and then come back. Whatever is the time in your regions, okay? Take 10 minutes break and come back. Hey, hello everyone. Are you all there?
Yes.
Yeah, Barney.
Wonderful, wonderful. So we can proceed further. Okay. So we just discussed about the first moment business decision, right? And the formula is very important here. If you look at the formula, it's summation of xi upon n. And when you do this calculation for population, it is called as population parameter. And it is denoted using mu. And you see a capital N. Capital N means we are speaking about population. Okay. If you calculate these for sample, it is called as sample statistics. It's called as sample statistics. And it's given a notation x bar. And you have a small n. Median is the middle value. Mode is the most occurring value. We know that. Hey, here is a small puzzle riddle for you all. Say two data scientists, two of the people who are attending here, say you both went to jungle for hunting, of course, and then you came across lion, and the moment you came across lion, there is no escaping. So Mr. A aims at the lion and releases the arrow, which misses the lion from the left side. And also Mr. B aims at the lion and releases the arrow, and it misses lion from right side. One arrow missed from the left, another arrow missed from the right, lion chasing at you. But these two people jump with joy. They hug each other. They say, yes, we made it. Why on earth were these two, Mr. A and Mr. B, happy? Yep. Any thoughts, anyone? Come on, brilliant minds, analytical minds, you should be able to solve this. Let's see who will get it right. I see responses coming, and let me see. These two people, Mr. A and B, have gone to jungle for hunting. They see a lion charging at them. Mr. A releases an arrow and it misses the lion from the left side. Mr. B releases an arrow and it misses the lion from the right side. But both of these people jump with joy. Why? No, they clearly know that they missed the arrow, missed the lion. They clearly know that.
Are they trying to scare the lion and not trying to kill the lion?
No, they wanted to kill the lion actually, because otherwise it will kill them. Survival. It's something like this. No, lion didn't run away, and lion was chasing at them. And if you release an arrow, lion will charge at you even with more, it will charge at you with even rapid pace. No, there is, that's an interesting thing, Aditya. No. Okay. It's something like this. Let me see now whether you'll be able to answer or not. It's lockdown time, and I'm sure a lot of husbands are doing a lot of household work, and the weight is significantly dropping. And say the weight of husband is 40 kgs. Is 40 kgs underweight or overweight? What do you think?
Underweight.
Underweight, certainly. Yeah. Yeah. If they are doing complete household work, then obviously they reduce their weight, right? And then say wife's weight is 100 kgs. On a jovial note, okay. Is 100 kgs overweight or underweight?
Overweight.
Obviously, overweight. When I take an average, what would the average be?
70 kgs.
70 kgs. Is 70 kgs right weight?
Sure.
Yeah.
Mm.
So one is underweight, another is overweight. On an average, they are of right weight. So both wife and husband enjoy and party together, saying that, yeah, we are the fittest people on the planet because on an average, we are doing well. Now, can you answer why these two people are jumping with joy?
Or they're thinking on an
They
average,
imagine
they're
the
not
goal in
getting
mind.
Ah, they imagine that. Yep, absolutely. On an average, we kill it. One left by when one missed from the left, another from right. On an average, we killed it. Jump with joy while lion attacks and eats these two guys.
So practically that line example, you cannot really tell because while they're jumping happily with joy, they might get killed.
They might.
Or they really didn't shoot the arrow at the lion. The lion is still charging at them, right?
Yeah. Yeah, but is this example apt then?
Yes.
Yeah. So you agree that you agree on who works a lot at home, right? Okay. So now there is second moment business decision. I'll give the same example of 7-Eleven. 7-Eleven has its stores across, say, ASEAN market in Malaysia, say Singapore, and Indonesia, and in various other countries. Here, here, the first question as a CEO would be, on an average, what are our sales? On an average, what are our profits? On an average, how many people do we hire? On an average kind of questions is what you ask. The next set of questions which any CEO or senior leadership or management person should ask and would ask is there any variation in the sales across these countries? Is there any dispersion in the profits across these countries? This should be the second question that a management person should ask and would ask. And hence it is called as second moment business decision. Mean, median, mode are first moment. This is second moment business decision. And here, let us take Malaysia and Singapore. Say you have 6 months data, 6 months sales data of Malaysia and another 6 months sales of Singapore. If you have 6 months sales figures, can I take an average of that? Can we do that? Can I take average? I have 6 months sales data, month 1,
Yes.
month 2, month 3, month 4. Can I take an average, friends?
Yes.
Yeah.
Oh, yes, right. That average is this line, assume, for Malaysia as well as you have for Singapore. Now, say the first month sales in Malaysia was above average. Second month, you were below average. Third month, it was here. Fourth month, fifth month, sixth month, in that way. Now, what is dispersion? What is variation? Dispersion of or variation means how far away is each point from the average. How far away is each point from the average? How far away is each point from average? How far away is each point from the average? How far away is each point from the average is called as dispersion. It's called as dispersion. Okay, so let me then talk about Singapore. Singapore, say the first month sales was way above average. Then second month it was low. Third month it was here. Fourth month it was very high. Fifth month and then sixth month. So what do you mean by dispersion? How far away is each point from the average? How far away is each month sales from the average sales? How far away is each month sales from the average sales, right? That's called as dispersion. Now, if you look at the dispersion here in Singapore, dispersion is more. There is huge dispersion. Here, the dispersion is less. Okay, here the dispersion is less. And here there is huge dispersion. Now you tell me, if you're given an opportunity to predict or forecast the sales for the next month, where would you be more comfortable? Would you be more comfortable with the data of Malaysia, or would you be more comfortable with data of Singapore in predicting or forecasting the next year? Why? Why is that so? You're right, but why is that so?
Dispersion is very
Because
less.
there is no more
Less
dispersion. Yeah.
accuracy not.
The
Exactly.
accuracy might be better.
Exactly. If the dispersion is less, then uncertainty is less. The values, the future value, the next predicted value would lie in this range. But when you look at this, the next value can range anywhere in this. So the uncertainty is more here. Here the uncertainty is less. Hence dispersion matters. If there is more dispersion in your data, what does that mean? That means that your predicted values or forecasted values will not be of, would not be very accurate. You cannot rely on it significantly. But if the dispersion or the variation is less, you can actually rely on the data because the dispersion is less. All with me?
Yes, sir.
And it is also heavily used in certain interesting scenarios like US FDA. Let me ask this question even before I proceed further with this example. How many of y'all like chocolates, eating chocolates? How many of you like chocolates? Yeah. Come on, you can respond. I mean, not much, but yeah, you like it, right? You love it. Okay. How many of y'all are vegetarians here? Mm-hmm. There are a lot of vegetarians, huh? Okay. I'll spoil your mood. Okay. So here, according to US Food and Drug Administration, how many insect fragments are permitted in 100 grams of chocolate?
Is this like that balanced, imbalanced thing, maybe less than 30%?
I'll let you know. So, I mean, you do not usually, I mean, people do not permit it. Yeah, I mean, if there are more than certain number of insect fragments found in chocolate, they reject that because they don't purposefully put insects into chocolate, but then it's very sweet chocolate. So flies somehow get into the manufacturing process and then they fall into the chocolate manufacturing cream and all that. So if the number of insect fragments are more than certain count, they reject the chocolate. It's not healthy for you. What is that count beyond which it's not permitted? Any thoughts? I'm sure you all want to say 0, but it's not 0 certainly.
10%.
Ah, 10% of what? I mean, when I say insect fragments, I'm speaking about eye of a housefly, head of a housefly, neck of a cockroach. Yeah. So I'll US FDA and insects Wikipedia. Do you see this? In chocolate and chocolate liquor, on an average, if you have more than 60 insect fragments, it is rejected. Until 60, it's not rejected. It's safe to consume. Protein, free of protein, you can consume that. Now, how many of y'all vegetarians have never had chocolate in your life? So did I prove that you're not vegetarians? Did I convince you? Not yet? Okay. And that means 60 is upper limit. This is according to US Food and Drug Administration, friends, which has world's highest standards. And then, okay, how many of you like orange juice? Now you cannot say you don't like, yeah? I want a genuine response. Orange juice, and that too, there is something called as pulpy orange from Coke, Coca-Cola, pulpy orange. Pulpy orange, it tastes very natural, right? Did you ever taste that? And the pulps inside the pulpy orange, those pulps are going to taste very natural. Yeah, you all liked it. Okay, now question to you all is, in 250 ml of canned citrus juice, how many fly eggs do you think are permitted? Have you ever seen Drosophila or fly eggs?
I guess this is first time I'm hearing that fly lay eggs.
Oh, is it? Then you have to also watch that. Yeah, that's how the egg would be. Yeah. So it would be exactly like a pulp. So next time when you consume pulpy orange, and if you feel that, wow, it's so natural, you also have to think on what else could that be. And according to Food and Drug Administration, how many, where is a canned citrus juice? 5 or more Drosophila or fly eggs, if you find, then it is rejected. Otherwise, you consume, you get into the illusion that it's so natural. Yeah, it's natural. So I can spoil your mood even further. When you go to movie theaters, what do you have during your break? Popcorn. Do you know what is measured in popcorn? Okay. You don't even drink water, is it? Okay. So people, vegetarians, now are you convinced that you all are non-vegetarians? If not, I can give you another example also. If you say, okay, I'll move on. Quite convinced. Perfect. All right. So this one thing in popcorn, do you know what? You all know about squirrel, mouse, rat. Yeah. Actually, mammal excreta is measured in popcorn. How weird. But then, yeah, it's what it is. Okay. Now let us understand about variance, standard deviation, and range. And you know that these are the second moment business decisions. So put it here itself. Let me take weights of people in kgs. Say the first person's kid's weight is 10 kgs, another kid is 20 kgs, another kid weighs 30 kgs. Weight in units. Now, what is variance? What is measures of dispersion? We already discussed, right? How far away is each data point, that is each point of this random variable, how far away is that from the mean? How far away is each point from the mean? And then people square it and add it and divide it by n. So how far away is each point from average? That's what we want to know. Here, if you calculate mean or average, what is average going to be of all these numbers? It'll be 20 kgs. Okay, so you got your mu or x bar. Now here, what is the next step? How far away is each point from average? How far away is each point from average? So how far away is each point from average? How far away is each point from average? How far away is each point from average? And these are all in kgs. If you just do xi minus mu, each value, how far is it from average? And when you add them up, what would you get? You'll get 0 kgs. Does that mean there is no variation among the weights? No, weights are varying. Weights are varying. And here, how can you say it is 0? Hence, one of the bright minds in statistics, they thought, a few of the bright minds thought, let us square it. And when we square it, this minus 10, if I square this minus 10 and say square, you get 100. And the units become kgs square. Units also get squared, by the way. 0 square is 0 kg square. And 10 square is again 100 kg square. Then if you calculate variance, what is variance? You add all these numbers. So if I were to expand this, if I substitute I equal to 1, x1 minus mu whole square plus I equal to 2, x2 minus mu whole square plus I equal to 3 would be x3 minus mu whole square. You divide it by total count, which is 3. So it's 100 plus 0 plus 100 because xi minus mu whole square. And then you add them up and divide it by 3. So that's what we are going to do now. If I add all these three numbers, you get 200 divided by 3 because you have overall 3 weights and kg square. Now if someone asks you on what is the variation among the weights, if you say it is 66 kgs square, 66 kg square, then people will be confused. Your management people will be like, oh my God, what are you speaking about? It's 10 and 20 and 30 kgs. The maximum difference that I see is 10 kgs. Why on earth are you saying it is 66 kg square? Kg square doesn't make sense. Then again, another bright statistician thought, okay, do you know what? To counter this negative and positive values, we have squared. Because we have squared, we are getting such weird results. Now let us again take back the square root, get back the units by taking square root of variance, and square root of variance is given a different name called as standard deviation. And it is very simple. Just take the square root of this number and then you get kgs. You get back your original units as kgs. Job done. So now if someone asks you on what is the variation among the weights, you say that it's 8 kgs. That's the relationship between variance and standard deviation. Number one, no matter what data you take, no matter which, how many ever data points you want, you can take. Whatever numbers you want to fill, you fill. When you take an average and subtract each value from the average, when you take average and subtract each value from the average, and then when you add them, you get 0. Always you get that. To counter that, we are squaring it. Here you see square to counter that. But when we square, the disadvantage is that units are getting squared. To get back the original units, you again take the square root of variance and call it a standard deviation. And usually in practical settings, people use standard deviation as a measure to calculate. Hey, is my sales fluctuating? Oh yeah, sales is fluctuating by $8, so on and so forth. Those kind of statements can be made. And there is also another measure which is called as range. Range is given as maximum value minus minimum value. The maximum value here is 30. So you say 30 minus the minimum value is 10. So the range is 20 kgs. Again, a riddle. Let's see who will come up with the most innovative response. Say you and your friend have went on some vacation. You and your girlfriend have gone on some vacation, right? And you have to move from one point to another point, and there is river flowing. And since you went with your girlfriend, you exhausted your complete money, assume. Yeah. Okay. Again, on a jovial note, yeah. No offenses meant. All right. And then you both don't have even a single penny to pay to this boat who is transporting people from one place to another. When you check with them, this person who was sitting on the boat told, no, I am not going to onboard you until and unless you pay me. Both of your height is say 6 feet. You ask this person on, hey, what is the depth of the river if we were to cross by walking? This person says average depth is 3 feet. You both don't know swimming, but your height is 6 feet. Average depth is 3 feet. Would you cross from would you cross the river from point A to point B by walking? Yeah. Would you do that or would you not do? Let's see who
No,
gets it right. Why would you not, Naveen?
because it's average. Maybe somewhere it may be 9 feet.
Exactly. Somewhere maybe the depth is 1 feet, somewhere maybe the depth is 10 feet. So you feel that it's a career ending move. It would be a career ending move, right, Naveen?
Yes.
Yeah, you might lose your life. Yeah, so a better way of asking questions should have been, what is the range of the depth? What is the minimum depth and what is the maximum depth, right? You should have asked that. What is the minimum and maximum depth? Hey, can you let me know? Should have been the right question range. But then any other innovative thoughts? There was an innovative, sorry?
Question. A range is usually like two, right? Like a range is
Yeah,
this.
minimum,
But how can it
maximum.
be one, like 20 kgs? How can it be one number?
No, it's minimum minus maximum. It's 30
Oh,
kgs to 20 kgs, to 10 kgs. What is the variation, right? Dispersion. Dispersion, variation. What is the dispersion of your values? You'll say 20. 20 kgs is what it's varying, meaning from 30 to 10. Okay. There was one very, very innovative answer which one of our other participant has given. That was, I would rather stand here because I spent money on my girlfriend. I'll ask her to cross. If she reaches safely, then I will cross. That was an innovative answer. I mean, analytical. Okay. So here, what's the time do I have? Yep. So here, population, when you calculate variance for population or standard deviation for population, it's given a Greek notation. Greek notation. Sigma square, sigma, and these are called as population parameters. When it comes to your sample, it's given S square and S notation. Of course, standard deviation is square root of variance. Capital N is population, small n is sample. But then then mu is for population, X bar is for sample. But then you might ask me this question on, here you have n, here you have n minus 1. Why is that so? We didn't have this kind of a difference here. Here it's capital N and small n. We did not have that difference here, n and n minus 1. What is this? Okay, let me answer, let me explain this and then we will take a break. So say you have population data, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just taking some population. Sample, say randomly I'm picking up a sample 1, 3, 4, 6, 7, some sample randomly I've taken that. And then if you calculate the, say, standard deviation of population, then the formula is standard deviation dot P. If you see dot P in your Excel, that's for population. The population standard deviation is so much. And what is the formula for population? You all know. Summation of I equal to 1 until n xi minus mu whole square divided by n. This is the population standard deviation. For sample, it is summation of I equal to 1 until n xi minus x bar whole square divided by n minus 1. You know that. And then, of course, square root.
hey, just one
Yeah.
silly question. Can you give
Yeah.
an example on how standard deviation is used?
Okay, what is the variation in your sales? That's a question which your management would ask. Your management would ask you on, okay, I'm giving you the sales of the organization or the branch which is in Malaysia and the branch which is there in USA. Sales. Is the sales across these two locations more or less in the same range, or is the sales in Malaysia fluctuating a lot and in US is the sales not fluctuating a lot? Can I depend or is there more certainty in the sales in US in comparison to Malaysia? If there is too much of fluctuation in the sales in Malaysia, then I'll talk to my vice president sales of Malaysia and check with him on why is it that in 1 month the sales is very less, in another month the sales is very high. Can you actually bring in more discipline into the sales process? I can talk to my vice president, right?
Got it. Thank you.
Yeah. These are all used to take business decisions. For giving bonus to your vice presidents, somewhere if the fluctuation is less, that means they have streamlined the processes. So you might want to give more bonus to your vice president of sales or head of sales. Okay. So here we have population, standard deviation. Okay. Now for sample, if I apply the population formula, for sample, let's see what happens. It's 2.13. But then if I apply sample formula, okay, if I apply sample standard deviation dot S on the sample, look at what's happening. Now question to you is, if I apply population formula on a sample, then is that closer to the true population? Or when I calculate standard deviation of sample using a sample formula, is that closer to true population? Which one is closer?
Sample. Standard
Ah,
deviation.
okay.
Sample.
This is the reason why there is n-1, because when statisticians used n-1 in the denominator, they found that the sample values were closer to the true population, because you don't work on a population, you work on a sample. But then when you work on a sample, whatever analysis or insights that you draw from your sample should be more or less similar to population. It cannot so happen that population gives you an entirely different number in comparison to sample. Making sense? Why not n-2? Statisticians are intelligent people. They have tried with all the possibilities, n-2, n-3 and all that, and they found that only when it was n-1, it was closer to population. That's the reason.
When you say sample is basically data of anything related to that population.
Yep, exactly. Exactly. Sample is anything which is related to this population. Yeah. All right. So we covered good ground. Today we discussed about where did that go? Yeah, here. We discussed about probability. We discussed about probability distribution. And then we discussed about descriptive analytics. If you remember, we discussed about first moment, business decision, second moment, business decision, mean, median, mode, and then we discussed about variance, standard deviation, and range. This is what we have discussed, and then Saturday and Sunday we will not be having classes, but then watch the recorded videos and attempt assignments pertaining to module 1 and module 2. Whatever you can answer. Okay, try to answer. That's what I would say. Expected value is one small concept which is left out, but then we are running out of time, so we will cover that on Monday. Have a great weekend, but I would recommend this. Watch the recorded videos at least 2 times. At least 2 times. And with respect to attendance, I would request you all to use your QR scanner And please scan this for Friday. From today onwards, we will start looking into the attendance.